Assalamualaikum everyone. Welcome to my video tutorial for high school physics students. In today's episode, I will be explaining the mathematical analysis of image formation by a lens system. So stick around, watch and learn. The question is, a converging lens, lens 1 in the diagram, 30.0 centimeters from a candle produces an inverted image of the candle on a screen 30.0 centimeters from the other side of the lens. A diverging lens, or lens number 2, is then placed midway between the candle and the other lens. When the candle is moved back 10.0 centimeters from its original position, its image reappears on the screen. Question: find the focal lengths of the two lenses. For our initial solution, we are given the distance between the object and the converging lens, L sub 1, denoted here by this of O, which is equal to 30.0 centimeters. The image is formed on the screen, alright, 30.0 centimeters on the right side of the converging lens. Hence, the image distance, d sub I, is equal to positive 30.0 centimeters, which suggests that the image is real. Remember, only a real image can be formed on a screen. One of our target variables is the focal length of the converging lens, denoted by small letter f sub 1. And to compute for the focal length f sub 1, we are going to use the derived formula f sub 1 equal to the product of d sub O times d sub 1 divided by the sum d sub O plus d sub I. And substituting into this formula, we have f sub 1 equal to 30.0 centimeters times 30.0 centimeters divided by 30.0 centimeters plus 30.0 centimeters, and we will get the focal length of the converging lens f sub 1 equal to positive 15.0 centimeters. The first image formed by the diverging lens must be located on the same side as the object or the candle because it is always virtual. And this is denoted by d sub I2, right? So that is yet to be determined. Now, that distance or that image formed by the diverging lens will become the object, okay? The object for the converging lens L1, or d sub O1, the distance of the object from the converging lens, d sub O1, is just equal to 15.0 centimeters plus the value of d sub I2. All right. This d sub I2 is supposed to be a negative value because it is located to the left of the diverging lens. All right. Now, as far as the converging lens is concerned, uh, the image distance, this of I1, is still equal to 30.0 centimeters. And its focal length, F1, was already calculated earlier, which is positive 15.0 centimeters. All right. So, for us to be able to determine d sub I2, we are going to use the thin lens formula, which is already a derived formula. That is, focal length f sub 1 is equal to the product of d sub O1 and d sub I1 divided by their sum, d sub O1 plus d sub I1. Alright? F sub 1 is given, or we already know the value of f sub 1. We also have the value for d sub I1. So, we will first isolate d sub O1 and then substitute for that what we have here, d sub O1, which is equal to 15.0 centimeters plus d sub I2. But first, we have d sub O1 isolated into an equation such as this. So d sub O1 is equal to the product of F1 and d sub I1 divided by d sub I1 minus f of 1, where we will substitute d sub O1 that is equal to 15.0 centimeter plus d sub Y2, all right, to the left side of this equation. That is 15.0 centimeters plus d sub I2, okay, equated to the product of F1, which is 15.0 centimeter, and d sub I1, which is 30.0 centimeter, to be divided by d sub I1, which is 30.0 centimeter, minus f sub 1, which is 15.0 centimeters. And so doing our math, we will be able to get the value of d sub I2 equal to 15.0 centimeters. But we know that this image distance, d sub I2, is the distance of the image formed by the diverging lens. All right, so as we have emphasized in this diagram, it is formed to the left of the diverging lens, meaning it is a virtual image. All right, and the image of diverging lens is always upright and it is always reduced in size. Alright, so in a short while, we will proceed in calculating for the focal length f sub 2. That is the focal length of the diverging lens, and we will be using this computed value for d sub I2, which when incorporated into equation number 1, it should have a negative sign because, as we've said, the image is virtual. Once again, we emphasize that the image formed by a diverging lens L2 is always virtual, so it must have a negative sign. Alright? di sub 2 or this of I2, okay, must be negative 15.0 centimeters. And going back to equation number 1, alright, which says that the focal length f2 is just equal to the value of the object distance d sub O2, which is 25.0 centimeters multiplied by d sub I2. Alright? Then divided by their sum, 25.0 centimeters plus d sub I2. Alright? Or substituting completely, we have 25.0 centimeters times negative 15.0 centimeters. Alright? Then divide this by 25.0 centimeters. Alright? Minus 15.0 centimeters. So doing our math, we get the value for the focal length f2 or the focal length of the diverging lens equal to negative 37.5 centimeters. Alright? So, to summarize, the computed focal length of the converging lens, alright, earlier calculated, is positive 15.0 centimeters, while the focal length of the diverging lens is negative 37.5 centimeters. And that concludes our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.